Good afternoon, advanced algebra students. I hope you are doing awesome. We are now jumping back into our Algebra 2 book after having been gone for a while. As you probably recall, we did lesson 2.1, 2.2, and then we started lesson 2.3. But we were not able to finish it because we needed to take a detour into our Algebra 1 book to learn some more about factoring. And now we're coming back to our Algebra 2 book to finish section 2.3. So the title of this notes is going to be 2.3b, factored form of a quadratic equation. So there's a little bit of vocabulary in here and also a little bit of mechanics in here. Now that we've learned how to factor a quadratic equation, we can discuss what it means to call something a zero. So let's take a look at example 1. If we have y equals x squared minus 9x plus 20, if the question says to me, what are the zeros of that function, it is essentially asking what are the x-intercepts. In order to answer that question, we can factor the quadratic. So we can write this as x minus 5 times x minus 4. When I graph this, what it means is that my parabola has intercepts at 4 and 5. So this parabola would have x-intercepts of 4 and 5, and that is equivalent to saying the zeros are 4 and 5. So zeros and intercepts are interchangeable. Another common word that we use to describe those is the roots. So the roots of this function are 4 and 5, or we could say the solutions to the quadratic equation are 4 and 5. They all mean exactly the same thing. All right, so let's go ahead and talk about how we can do a problem algebraically without graphing. So example number 2 is to solve x squared plus x equals 42. So the first thing we always need to do is to set our equation equal to 0. And so what we're going to do is subtract 42 from both sides. So we're going to have x squared plus x minus 42 equals 0. So step 1 is to set the equation equal to 0. After we set the equation equal to 0, we want to factor. In this case, we're going to factor by trying to determine what two numbers we need to multiply to make negative 42 and add to make positive 1. So we're going to factor this as x plus 7 times x minus 6. Now, there's something called the zero product property that is super helpful and important. The zero product property tells me if I have two things that are multiplied together to make 0, one of those two things would have to be 0. So either x plus 7 would have to be 0 or x minus 6 would have to be 0. So after we factor, our third step is to set each factor equal to 0. Now these three steps here are super important. So let's do that. We're going to set x plus 7 equal to 0, and we're going to set x minus 6 equals to 0. This gives us negative 7 for x, and this gives us positive 6. Alrighty, hopefully that was pretty helpful for you. Let's go ahead and do another example. So example number 3, let's do 2x squared equals negative 9x plus 5. All right, I'd like you to look at the 3 steps and tell me what you think would go first. What would be the first thing that you would need to do? Well, we need to set the equation equal to 0, so let's move the 9x and the 5 over. So we're going to have 2x squared plus 9x minus 5 equals 0. Now we're going to factor. Notice that there is something other than a 1 in front of the x squared, and we can't take it out using GCF. So we're going to multiply the 2 times the negative 5 and ask ourselves, what are two numbers that multiply to make negative 10, but add to make positive 9? The answer would be positive 10 and negative 1. So we're going to rewrite this as 2x squared plus 10x minus 1x minus 5 equals 0. Then we're going to divide this into two groups, or separate it into two groups, and take out the 2x here. 2x times x plus 5 minus 1 times x plus 5. After that, we regroup, and we get 2x minus 1 times x plus 5 equals 0. So all of this work here was just to do step 2, factor. After we factor, remember, we want to set each factor equal to 0. So we're going to have 2x equals 1, or x equals 1/2. And here, when we set x plus 5 equal to 0, we're going to get x equals negative 5. So those would be the two solutions, the two roots, the two intercepts, the two zeros of the function. All right, let's go ahead and do example number 4. I'm trying to give you a lot of examples of these because they are fairly important. So I'm going to read a word problem to you, and again, all you need to do is write what I put on the board. Marco hits a golf ball into the air from the 3rd level of a driving range that is 48 feet high. The function h of t equals negative 16t squared plus 32t plus 48 gives the height h in feet of the golf ball t seconds after it is hit into the air. When will the ball hit the ground? So in this particular case, what we're looking at is setting this equation equal to 0, because when it hits the ground, the height will be 0. So we're going to set negative 16t squared plus 32t plus 48 equal to 0. Then we can see that there's a GCF of negative 16. When we take negative 16 out, we get t squared minus 2t minus 3. We can further factor that as t minus 3 and t plus 1. Let's set each factor equal to 0. Now clearly, negative 16 can't be 0, but t minus 3 could be 0, which would give us t equals 3. Or we can set t plus 1 equal to 0 and get t equals negative 1. Now obviously, in this real world context, time only makes sense if it's positive. So we're going to cross off the negative 1 and keep the 3. So the ball is going to hit the ground after 3 seconds. Okay, so those were examples where we used factoring to solve a quadratic in a variety of instances. In addition to using factoring to solve quadratics, we can also use factoring to identify the intervals over which the quadratic function is positive or negative. So let's go ahead and look at this next example, and I believe it would be example 5. Hopefully I'm right about that. And this equation is y equals negative x squared plus x plus 6. So I'm going to take out the negative 1 so that I have x squared minus x minus 6. When I factor using our tool for x squared plus bx plus c, there can only be a positive 1 in front of x squared, so that is why I took out the negative 1. When I factor my x squared plus bx plus c, I'm going to have x minus 3 times x plus 2. Now, if I would like to graph this, I know that I'm going to have intercepts at 3 and negative 2. So I'm going to put a dot at negative 2 and another dot at positive 3. Remember, this is in the form y equals a times x minus p times x minus q. So for example, this is telling me that one of my intercepts is 3. And if I think of x plus 2 as x minus negative 2, I can see that q is negative 2. So my two intercepts are negative 2 and positive 3. To find the vertex, I would need to go halfway between those two intercepts. So those two intercepts are 5 units apart, so half of 5 is 2.5. So I need to go 2.5 in from each intercept, and I know that my axis of symmetry is x equals 1/2. To find out what y is, all I do is plug in 1/2 for x and solve for y. When I do, I get that y equals 6.25. So if I plot my vertex, I would go up 6.25, and this would be a picture of the graph here. Now, if the question is, when is this graph positive? This graph is going to be positive between when x is negative 2 and positive 3. We can write that a few different ways. One of them is to say between negative 2 and positive 3 this way, or I could do negative 2, 3 in interval notation like that. All right, let's do one last example, example number 6. And I'll do that one on the board as well. It says, write an equation of a parabola with x-intercepts at negative 2 and negative 1, and which passes through the points negative 3, 20. Now, I believe that we discussed this in 2.3a, but it's been a while since we did that, so I think it's good to review it. The first intercept was negative 2, 0, so we'll call negative 2p. The next intercept was negative 1, 0, so we'll call negative 1q. And it passes through the point negative 3, 20, so I'll call negative 3x and 20y. Then, as you recall, what we want to do is fill in everything that we have to solve for y. So I put 20 to solve for a. So I put 20 in for y, and then I'm going to put negative 3 in for x. So I'm going to have negative 3 minus negative 2 and negative 3 minus negative 1. These become positive here. So I'm going to have 20 equals a times negative 1 times negative 2, or 20 equals 2a, or a equals 10. Now that I have an a, and I have a p, and I have a q, I can go ahead and write my equation here. It's going to be y equals 10 times x plus 2 times x plus 1. I know that was a lot to go over. I'm really looking forward to helping you in Zoom, and I hope you have a good day. Bye.